Hello, all you sixth grade mathematicians. This is going to be a little bit of sort of a deeper dive into one of the last things we talked about, which was the distributive property. So if you don't remember this distributive property from the last few classes, we're going to talk more about it here, but we're also going to kind of look at how we can generate some equivalent expressions from this property. As you probably saw in sort of the opening of the module, we're working on identifying equivalent expressions. So the idea that if I have this expression, I can do things that are mathematically sound or that have good mathematical reasoning to write expressions that are equal to this expression. So for example, if I've got 3 times 4 plus 5, if you did the last module, normally you'd evaluate parentheses first, you'd get 4 plus 5, which is 9, and I could write this as 3 times 9. And then if you are really good at multiplication, or if you were to quickly grab your calculator, you could see that 3 times 9 is equal to 27. However, and so all of those are actually equivalent expressions. 3 times the quantity, 4 plus 5, 3 times 9, and 27. All of those expressions are equivalent to each other. However, I also could use the distributive property and say that this is 3 times 4, which is 12, and 3 times 5, which is 15. Notice 12 plus 15 also is equal to 27. Those expressions are all equivalent, and one of the reasoning we might use is this idea of using the distributive property. So right here, I've actually got 4 different expressions, and I could probably come up with a lot more. I could have written 12 as 3 times 4 plus 3 times 5, and that would be another equivalent expression. So I've actually got 1, 2, 3, 4, and I could give that 5th one too. All of those are equivalent, and so really this whole kind of module is about playing around with the distributive property as well as other kind of properties of operations to create equivalent expressions. With variables, it's the same kind of idea, that I can distribute, or I can think of this as 3 groups of all of these things. I've got 2a plus 5b plus 10. Well, I'm going to do 3 groups of 2a, which I can determine is 6a. Then I'm going to do 3 groups of 5b, which is 15b. And then I'm going to do 3 groups of 10, which is 30. And when I have all 3 of those, that is an equivalent expression based on the distributive property. Now, the one thing that's a little bit different with variables is I cannot combine things together that are not the same. If I thought of this as like a variable, I might think of this as 6 apples and 15 bananas and $30. I cannot combine apples and bananas. Those are 2 separate things. So I actually have to leave them separately. I can just write this as 6a plus 15b plus 30. That's the only kind of way I can manipulate that. Now I can write equivalent expressions that are equivalent to this, but I can't write 6a plus 15b and write that as, well, 15 plus 6, that would be 21. I got 21ab. No, those cannot go together because they're 2 different things. So make sure you're thinking about that as we kind of are unpacking some of this distributive property thinking. So if we kind of scroll down here, we're going to look at how we can use this property and under a bunch of different ways to be able to create equivalent expressions. One of the things I'm going to ask you to kind of report out in the discussion at the end of this video is, which one of these boxes makes the most sense to you, and why does it make an equivalent expression? And I really want you to try to be able to explain this as if it was somebody who didn't choose that one. So if somebody was to, like, let's say, choose box A that you feel like you really understand, but somebody didn't choose that one because they don't understand it, I want you to be able to explain why does it make an equivalent expression in a way that they would be able to understand it. So as you're looking at other people's responses, through the course of this sort of discussion, hopefully you'll get a really well-rounded understanding of all of these different examples. So let's look at all of these kind of separately. If I've got the distributive property as 6 times the quantity, and when I say quantity, I just mean the things in the parentheses, 6 times 2 plus 8. I can think of this as finding the area of a rectangle, which is something that we did in class, by doing this as taking 6 and multiplying it by 2 plus 8. Now some of you might say, well, I can just do 2 plus 8 is 10, and then 6 times 10, well, that's, or 6 times, sorry, said 10, I meant to write 8. 6 times 10, which would just give me 60. And yes, that is true. However, When I'm thinking of the distributive property, what I'm thinking about is I want to think about these as equivalent expressions. So yes, I could write this and say this is equal to 60. However, I'm going to use the distributive property to make an equivalent expression. I could do 6 times 2 and get 12. And then I could do 6 times 8 and get 48. So I could actually use the distributive property to write this as 12 plus 48. That is an equivalent expression to 6 times 2 plus 8, if I wrote 12 plus 48 by the distributive property. So notice that I've got an equivalent expression right here. 60, I've got 3 of them. 6 times 2 plus 8, I've got 60, and I've got 12 plus 48. All of those are equivalent, and if you chose this box, that's because of the area model. If I'm going to slide down, I'm going to come back to box B, but if I come down to C, a lot of people kind of remember it this way, that I'm just basically taking this and I'm distributing it to both of these terms. And if I do that correctly, I can actually do 6 times 2, which is 12, and then 6 times 8, which is 48. And then I can, because they are both numbers, actually simplify this and write that as 60. But those are kind of those two boxes. I have this is what we call the distributive model. This is what we call the area model and box A. So if you're going to choose one of those, I want you to make sure you're using the letter to decide that. There are other ways of thinking about this, though. If I think about this in box B as a multiple group, really this means 6 times this 2 plus 8, which means I actually want 6 groups of 2 plus 8. And when I'm thinking about that, I can actually kind of think about it like this. If I've got 2 plus 8, here's my one group of 2 plus 8, and then I add 6 groups of it together, I can also write an equivalent expression instead of using multiplication by using a repeated addition. So I could write the expression 2 plus 8. Let me get a pointer here. Oh, here, 2 plus 8 plus 2 plus 8 plus 2 plus 8 plus 2, and I would need to do that 6 times. That expression, if I was to add up all of those things, would also be equivalent. Notice, different than 12 plus 48 and different than 60, but I've got an expression that's much, much longer, but still equivalent. And in fact, if you add 2 plus 8 plus 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 2 plus 8, you should get 60, and that's because of that idea that these are actually equal groups of 2 plus 8. Notice this also allows us to simplify some really cool things. For example, I could write this as, if I took 2 plus 8 and 2 plus 8 and wrote that as 4 plus 16, I've actually got this group right here 3 times. 1, 2, 3. And so I could actually write this as 4 plus 16, and I have 3 groups of it, or times 3. And that would give me an equivalent expression. And if I was to quickly just check my work, 16 plus 4 is 20, and then 20 times 3, that's 60. So you can actually see that sometimes writing this out as repeated addition can sometimes help you be able to establish other equivalent expressions. So now if you notice, like if I'm just looking at this example, I'm going to kind of just put a check mark next to all the expressions that are equivalent. I've got the original problem, 6 times 2 plus 8. I've got 60. I've got 12 plus 48 because of the area model. I've also got 2 plus 8 plus 2 plus 8 plus 2 plus 8 because of that equal groups model. I've got 4 plus 16 times 3. I bet you if you're working ahead of me, you might be able to write this as a different expression, maybe making this into 2 groups of something. So this and this, for example. You can write that as another expression. But right now I've got 1, 2, 3, 4, 5 equivalent expressions that are all equal to our original expression of 6 times 2 plus 8. This idea is something that we're going to look at with variables in a second, in sort of a second video. But I'm going to kind of show you one other thing that can help you create an equivalent expression, and that is using this idea of factoring. Let's say I've got 12 plus 48. I'm going to start kind of with where I ended. What I can think about to make an equivalent expression is I can think about, instead of multiplying, dividing both of these by some number. Now I multiplied it by 6, But I'm going to think, well, let's say I use the number 2. If I was to divide out a 2 and write this as 2 times something, I can use that idea of pulling out a 2 from both terms in the same way that I multiplied by both terms, kind of in the opposite direction. That's actually called factoring. So for example, if I took 2 and I said 2 times what gets me to 12? Well, 2 times 6 is 12. And then if I did the same thing here, 2 times what gets me to 48? Well, if I did 48 divided by 2, that's 24. And in fact, this expression also is equivalent to that expression. And notice what I'm actually doing for this one is, instead of multiplying through like I did in the distributive model, I'm thinking about dividing this out and saying, okay, well, I know that I can take a 2 out of both of these terms. And if I divide them both out, then I've got sort of this 48, or I've got this 2 times 6 plus 24. Or if I did 6 plus 24, that would be 2 times 30, which actually is another equivalent expression. So you can see that I can use kind of this idea of the distributive property. Notice also I'm using a parenthesis here to represent multiplication. I can do that. I could use a dot. I could use a times sign, but I can do it in kind of lots of different ways. And sometimes it's just good to use different kinds of ways. But notice just using just this concept, I can use the same idea and I can come up with 1, 2, 3, 4, 5, 6, 7 different expressions that are all equivalent to 6 times the quantity 2 plus 8, or equivalent to 60. This idea is something we're going to play around with more when we go down to looking at the second video, which is going to be using variables. But I want you to just kind of quickly check in with what you're going to be replying in the discussion. Which one of these letters, A, B, C, or D, make the most sense to you? And why does it make an equivalent expression? And I would really encourage you to be able to try to explain it in such a way that if there was somebody who didn't choose, like let's say I chose this one, but I really didn't understand this one. If you choose this one, I want you to explain it in such a way that if the person who chose this one didn't really understand this, that they would be able to make sense of it. And that's going to be something I'm going to really kind of challenge you guys to think about during this or exit ticket. So we are going to look at another example with letters, and I would encourage you to kind of continue to think about which one of these you're going to choose in the discussion, but that's the kind of heart of what I want you to think about. I'm going to go to video 2, where we're going to look at the same concept with letters, and I'd encourage you to go there right now. All right, thanks.